Okay, the second problem is about linear approximation or Newton's method. Newton's method is just a simplified way of repeatedly doing linear approximation. But so, what does the question say? It says the polynomial blah blah blah. It's a fifth degree polynomial. Has a root approximately but not exactly at x equals 0. So when I created this problem, I checked this with a graphing calculator so that I know it's true. So if you graph this thing near 0, it looks kind of like this. So here's 0 and the polynomial goes kind of like that, and this is very close. So this distance is small, like 0.000 something. Maybe not that small, but it's small. So part A says find the linear approximation to f at x equals 0. Okay, and we're going to use the linear approximation or Newton's method to generate an improved estimate of the root of f near 0. So let me show maybe a better picture of what's going to happen here. So there's a y-axis, there's an x-axis, and let's say the curve looks something like this. Okay, so the linear approximation near 0 is going to be something like that. Okay, so we'll figure out the equation for this thing. This is what is being called L. Okay, so this is the linear approximation of the f curve, which is in black near 0. And then for part B, we'll just solve, we'll solve L of x equals 0. Alright, and that will tell us this point, which, as Newton observed so many years ago, has a tendency to be closer to the actual root than where we guessed before. So our initial guess is 0, and our new guess is going to be this. We could call this x1. I've been calling the initial guess x0. Alright, so here's where our improved guess is going to be. You don't have to, and the update rule for Newton's method is this, but you don't really strictly need to know that, because you could just find, it's asking you to find the tangent line at 0, set it equal to 0, and solve. Okay, so there's nothing more to it than that. So don't let all this notation and theory intimidate you. And on the bottom here, there's f prime of x0. Alright, and so that is a fast way to find this x1 thing. But let's just go ahead and find the whole linear approximation. And again, there's kind of a complicated thing is being made simple. So here's the point 0 comma f of 0. And what is f of 0? You can see it's just the constant part here is minus 1. That means my picture is completely wrong, but let's just ignore that, okay? So the function must be increasing through this root, but it's just the reflection of what I've drawn across the x-axis. So that point is on the curve, and what this is going to be is just the tangent line to f at the point 0 comma minus 1. And so that's just, you need the equation for a line that goes through this point and has slope f prime of 0. And why is that true? That's because that's exactly what the derivative means geometrically. It's the slope of the tangent line. So this is just point slope form of a line, so you could figure all this out with your point slope formula. And how does it go? So this is m times x minus x1, okay? So this is where x1 and y1 are the given point. So here's the given point, and m is the given slope. So m is f prime of 0. So then you just move this over, right? Okay. But for better or worse, in the linear approximation chapter, you can memorize a formula that lets you go directly to L. And if you want, you know that the equation for L turns out to be f of a minus f prime of a times x minus a, And so this is the linear approximation at a, and in our case a is equal to 0. So what do all these things turn out to be? So f of 0 is -1, like we said. And what is f prime of a? I mean, you can just see that it's 10, right? Because you take the derivative. When you take the derivative, 10 is going to be the constant part. Then when you plug in a equals 0, the only thing that is left is going to be the constant part. So you don't know what I'm talking about, then take the derivative and plug in 0. It's easy. So this is minus 10, and this is times x. Okay. All right. So this isn't coming out at all like I thought it was going to come out. What's going on? But I think that's okay. Oh, it's because this is plus. Oops, sorry. If I can be completely honest, my upstairs neighbor is smoking marijuana, and I think I'm getting a contact high, which is not a great combination with mathematics. Okay, but now we have the equation for L, which is 10x minus 1. And to find this point here, which is the answer, you just set the linear approximation equal to 0. So 10x minus 1 equals 0. And then x is equal to 1 over 10. Same thing as 0.1. And you're done. Okay. And I don't know what this root actually is. I made this polynomial up, and as you know, you can't solve 5th degree polynomials in general, and you probably can't solve this one. But if you really wanted to know, Wolfram alpha could numerically approximate the roots for you, so you could see how much closer 0.1 is. And that's it. That's it. Okay, great.